Automated hand watering versus hand watering. Hand watering takes time, it doesn't provide optimal water requirements to the plants, and it can actually waste water. While automated watering systems conserve water, doesn't require human intervention, and provides optimal water requirements for the plants. There's two options for automated watering systems. Your first option is non-soil moisture sensor watering. It uses a time-based watering schedule. It doesn't provide the best water requirements to the plants because it's not based on soil moisture, but it also does remove human intervention. While on the other hand, there's soil moisture sensor watering. It uses a soil moisture sensor to sense the wetness of the soil, in which case it determines if the soil is too dry and activates the plant watering. It also removes human intervention. So this is how it works. It uses a microcontroller like an Arduino Uno to control the automation. The water pump delivers the water. It gets the water from a reservoir bucket and transports the water to wherever it needs to go through water lines. It's about $6 for the price of that. An SSR outlet is a solid-state relay outlet, which is controlled digitally through the microcontroller, our Arduino. That costs $5 to create. Soil moisture sensor, which can be bought on Amazon, is $6, and you want to get a non-corrosive one because it's going to be in water and you don't want the metal to be rusting over time. So this is a really more efficient way of doing it instead of ones that are corrosive. If the soil sensor is determined to have a low value, then it turns the SSR outlet on, which then turns on the pump. If the soil moisture sensor value is high, that means that there's too much water, it's too wet, and then we turn off the pump. And then after that, this system, the microcontroller, looks at these values forever because it's in a loop. So the loop is constantly checking, is the sensor value high or is the sensor value low? If the sensor value is high, that means the soil is wet, which means to turn off the pump. If the sensor value is low, that means the soil is dry, which means to turn on the pump. So right here we have our Arduino Uno, our microcontroller, with the SSR plugged into the ground and digital pin 13, which we can also see coming from this line right here. This is what activates the SSR outlet, which allows power to run through it into the pump, allowing the pump to pump water. Here's our SSR outlet, which is connected to the pump and also a Leeds AC line. And then here's our microcontroller again, and then this is our soil moisture sensor. As you can see, this little U-shaped right here, that would usually, on a non-corrosive soil moisture sensor, actually on a corrosive one, it would not be covered. This way we have it, it can be in the system indefinitely and not corrode over time, which is good to not have rust where you're planting stuff. And then right here is our submersible water pump in a reservoir. I've actually just used a pot right now, just as an example. And here we have a video of the system working. As we see, we plugged in the system. It notices that the sensor is not wet at all, so it's running constantly. Once it goes into the water, the pump stops, and vice versa. This was really good, and nice example showing how the system actually works. So, in conclusion, I've shown how a soil moisture sensor-based automated watering system works, how simple it is, and the cheap cost of it. The total is only around $21, I think, for parts, which also includes a very long line of tubing. I showed this system to some people, and they were actually surprised at how cost efficient it was and how cheap it was, and was wondering if I could build them some so they wouldn't have to water their plants in the future, and instead use this automated system to provide optimal watering solutions and less resource waste to their systems. So thank you for watching my project. My name is Thomas Ciano. Thanks and have a wonderful day. Bye-bye.